So he probably not be really back,
Yeah.
Uh, you know. That's interesting. Okay, you want to start it?
Yes, yes. Let's first share my screen. Uh, Hi, good morning and good evening, everyone. This is our second discussion for the online FVCOM course algorithm and training for 2026 spring. So for this week, we should go through the part two and part three of the lecture three, the FVCOM formulation and the finite volume discrete method. So if anyone has any question related to lecture three, so you may raise it up here.
Mm, yeah.
I
The student has posted a question on the website on the course website. The,
I checked today. No, not yet.
oh, okay, good.
Mhm.
Okay, now I think Troy had a question. Young
Okay,
Me, you had a question? I saw that you was
I have a question for
okay,
you.
yeah.
yeah.
Yeah,
Do you want to
hello,
share your screen?
Mhm.
me.
Uh-huh.
Yeah,
Yeah, okay.
uh, yeah,
You can show your screen. You know how to
yeah.
show the
I'm
screen?
looking for
Yeah, and I tell you why
where
this.
can I?
Share screen should be, I think it should be, oh, I didn't find a share screen. I didn't find a share
Yeah,
screen either. Okay. Oh, yeah, here. You see on the right, you see the word,
yeah,
you had a green, side, put a
yeah,
share. You click there, it should be okay. The green, though you find the green box.
yeah.
In the
I
green
see
box,
the
in the
green
bottom, you click,
check mark. You may,
yeah, you click that.
yeah,
Then
but it's still not.
yeah, yeah,
There
then
is
you click your
nothing for
screen.
sharing the screen.
Yeah, green. So you wanna Sichi can take a picture, send it in
Okay,
the
I
chat.
can ask it
Yeah.
verbally without sharing a screen,
Okay.
maybe. Yeah, as I'm working in the context of the S3
Okay.
with a sharp salinity fronts, I have a question about the formulation of TVD with upwind. That when
Yeah.
would you recommend using TVD over second order
Oh.
upwind? And what diagnostic would you check for checking
Mm,
which one is more accurate and when we can use which one of them about
mm.
the TVD and upwind formulation.
That's a very good question.
Professor Chen,
Uh-huh.
Professor Chen, I'm so sorry. Yeah, I
Mm.
think it is better to get the old question at the beginning.
Okay.
And because, yeah,
Yeah.
we already have experienced this kind of before. So,
Okay.
why don't you, and I think it is better to send the PPT or question slide before the class. Then CHD might have enough time to prepare. So I
Oh,
think
yeah.
I know that
That's
some
yeah.
of the students have another question, so please bring it up.
Yeah, I think that's the last time we suggested students in a question, but sometimes everybody busy, they probably don't send. But I think that I like your suggestion. So let us write down all questions. No, just write down, listen all the questions, then we can answer together. This way, we don't want to have one question stay the whole hour, right? Okay, good. Yeah. So who else have a question?
I have some questions.
Oh my God.
So I share my screen. So yeah. Yeah. So uh, my question is compile question. So I try to ESMF for every complete, and my configure setting is here. So I try to intercompiler
Mm-hmm.
for MVPC, but uh, I checked my compiler
compile results, but I found that some process ESF direct coupling tests is only one core is activated, even though the main process has over to 6 CPU, but just only one CPU is activated. So, did you have experienced this issue? I want to for your advice to solve this error.
Mm-hmm. Yeah, that's probably Dr. Lee can answer question. That's second question. Okay, good.
Mm-hmm.
Okay.
Yeah.
So do we have other still have other question?
Professor, I
No.
have a question.
Okay.
Can I share my screen?
Yeah. Yeah, definitely. Yeah.
Um, oh, I checked the FVCOM assimilation module source code
Mm-hmm.
and found that the SS stage assimilation system is
Mm-hmm.
set up for a daily input interval. However, in microtidal environments like the Yellow Sea, daily data is not enough to resolve tidal induced water level fluctuations. Also, in the Northwest Pacific, where currents and the tide mix in a complex way, uh, daily assimilation makes it hard to capture sub-daily variability accurately. So I want to know numerical ways to uh, simulate hourly water level and current changes uh, when the temporal resolution of SSH data is fixed at a daily interval.
Mm-hmm.
Yeah,
Yeah, that's a good question. Okay, I write down, okay. Okay, good. Have other?
okay.
Now we get a three question. Okay.
I have one
Yeah.
question.
Okay.
So in lecture 3, sorry, I didn't prepare the PowerPoint,
Mm.
but in lecture 3, in lecture they mentioned that usually the FACOM use the non-sleep condition for the lateral boundary.
Yeah.
And then I just wondered that so if the if we want to simulate the inundation case,
Mm-hmm.
and then how can we deal with that? Because for the lateral boundary, we have to set the non-sleep condition before we start the simulation. However, when the inundation can be a start, how the lateral boundary can work for that case?
Okay. Yeah, that's good question. Later I can answer you. That's
Mhm.
the fourth question.
Yeah,
Okay. Oh,
thank you.
we have other. Okay. Do we have other question? If you don't have, so I can answer the question one, question three, and question four. So then Dr. Lee will answer the question two. Is okay?
Yeah, definitely.
So it's fine. So
Yeah.
let me go through three questions, then you do the second question, okay?
Mm-hmm.
Okay. And now for the first question about FVCOM had a two scheme to the vaccine. And one is called upwind scheme, the second order. Another one's a KVD scheme. Okay, this scheme was implicated by European, I said Norway, scientists. I do have a slides. I can show you the slides there. We do have a comparison for two methods. But for temperature calculation, we found a KVD scheme is make a more accurate than upwind scheme. Okay, so that's why we really strongly suggest people if you do the temperature simulation, you better use the kind of TVD, right? Is my pronunciation correct?
Yeah.
TVD. If you're interested, I can show the results, but I need to find my older note. Okay, we have a fully comparison. The comparison down, we put a tracer one concentration, like put in the model, to run the model without any forcing. Okay, and the forcing, you want to see how the diffusion, because every numerical model has a diffusion that can be diffused, right? So you want to see which ones if you have a constant flow, the constant flow moving, this kind of no isolated tracer, they should be moving for the current. When they're moving, they also can be diffused, right? But then we found, so for we assume the diffusion equals 0, right? So then everything diffuse feature you come out is come from numerical error, numerical diffusion. Well, we assume mixing is 0, okay, everything there. So the testing come out, we found second order FVCOM version, is pretty good. However, compared with the QVD method showed more high accuracy. The numerical diffuse smaller than the kind of upwind. But depending on what question you want to address. But most time it's very safe to use the TVD method for the tracer calculation. That's why you ask me to which one you recommend. You can use both, no any problem. But then we found okay, particularly for you had a front system, front. So I think you better use the KVD method. Do I address your question?
Yeah, thank you. Because
Yeah.
I'm working in the estuarine context and estuarine circulation, so I'm dealing with the front between salinity, temperature, and fresh water, salt water. So
Yeah.
I think it's better to use the
Yeah,
TVD
totally. Yeah.
method.
But I didn't I forget to mention analysis. If you only use KVD and upwind skin, you don't see much difference. But however, if you compare the KVD and also what is that's the vertical one and the 17 了, remember the name?
The MP data?
NP data, right? Can you write down in the
Yeah,
chat?
I can share the screen.
Share screen, yeah. So yeah. So you see, yeah, screen. You see, if you use the TVD method plus the MP data, that's very important. Use the MP data. Okay. So this way you can get a tracer much better. You look about results. We put a square on a tracer in the model. We test that. You see upwind. You can see the diffuse. Right? You can see the no, it's upwind also is okay, but this of course resolution is high resolution. But you can see the upwind skin and also TVD methods, performance is very similar. However, you look about the grading, about the box there, and just on the right side, okay, right side, okay, you find, that's kind of grading, is more sharp in the TVD method than the upwind skin method. So that's why when you start for river discharge, like a prone structure, you want to get it's kind of front, okay, more accurately. So that's why we suggest using the TVD method. But meantime, be carefully, you have to include MP data. Okay, MP data is treated like a vertical, advection. Okay.
Yeah, thanks.
Okay. Yeah. Okay, you have more question about that? No, it's okay. Okay. The second question, that's a very good question about data assimilation. So, FVCOM only include SSH data assimilation for daily average. Because we get a satellite data from the global, what the level data is most daily average data. That's why we only can do the daily average data. If you want SST, SH simulation, you have to do it only to the daily. You're not able to resolve the daily, variation. But then the main problem come out. If you are in a coast region, so you want to use the like a SH simulation, you may cause a problem. The reason because you do the daily averaging, so that's why the FVCOM doing like this. You run the model for daily, right? At 1 day. After 1 day, you do the averaging with your water level. Then the water level averaging, there was a computer's difference in the daily model simulated daily averaging water level with SSH. You assume SSH is a daily averaging water level. So you compute both, then you get a difference. So then the fee can go back, either use the OI, either the nudging to just adjust the model for difference. Just adjust the model for difference, not for really simulation the water level. So just want to make sure after 1 day simulation, so you get your what model mean sea level is the same as your as the SH data. So the approach you use this way, you can make sure your model still without a tide, right? Still without a sub daily variability, right? So that's the reason. So that's why if you really want to do the water level simulation, so you can still simulation the SH satellite SH data into the model, but you have to use the traditional FVCOM approach. You have to do the running the model. Just you set the FVCOM simulation on, the model will run it 2 times. Okay, run the first time for water mode without a simulation, then get the mean sea level, then compare with the satellite sea level, then difference, then you rerun the model again to adjust difference. But then you sub daily, variability is still there. Okay, so you still resolve there. But you cannot simulate the SH data as the every time step. If you simulate if you direct the simulated the SH data into your model, so you will destroy all the sub daily. Okay, just any time variation smaller than the daily scale, you will be filtered. Okay, so that's reason the FVCOM doing sea level simulation, just to do the daily for satellite data, but still keep all we call a high frequency part, like a tides, like everything, the wind variability all include there. Okay, do I answer your question?
Oh, yes, thank you.
Okay, that's the second question. The third question is very good question. So if we can assume, so we are boundary condition we use the free sleep boundary condition. So that means every solid boundary we assume the normal flux equal to 0. The reason we don't use the non-sleep boundary condition is because if you do that one, you don't resolve the laterally boundary layer because you get a boundary layer. So most times you say, okay, velocity on the coast equals 0, right? So by problem, your model resolution not very high to the centimeter, right? If you model to the centimeter, you can assume velocity the boundary is 0. But the problem is you most like a 10 meter, 20 kilometer, 10 meter also some meter order, you not resolve like a viscosity, viscous lateral boundary layer. You not resolve this one, so you have to use the boundary theory. So this way, you're larger scale person, so you didn't see how the velocity go to 0 at the boundary. You only see the velocity moving along the boundary, right? So then your question is if you have a boundary condition, you have a wide dry point. What's really happened, right? When you have a dry point, that's not a boundary anymore. So when you include wet and dry, you get a flooding. So this point had a dry node and a wet node. In this time, not a solid boundary. This boundary condition not apply. Okay, this boundary condition only apply For solid boundary, they keep solid boundary permanently. If anything, you include a wet dry point, okay, you include a wet dry point, so that's not a boundary anymore. That's why this boundary condition not apply for there. Okay, that's why you don't have a problem. You get the water become the wet to dry, dry to wet. Kiwon, do I answer your question?
Yeah, and so
Yeah. So
okay.
if you had a grid, right? You had a boundary
Mhm.
condition, you say had a boundary condition, that's my solid boundary. You apply the boundary condition, it will normalize to flux equal to 0. But when your region had a wide dry point, it's not a boundary anymore. They don't treat the boundary, okay? So that's why they transport everything determine the sea level, right? If the sea level is over cover the dry sea, it becomes wet. That's why there's no boundary condition there. No boundary condition, okay? So we only say this velocity equal to 0, because when you dry, you don't have a velocity, right? You have a wet, you still have a velocity, right? If velocity, for example, the flooding period, you can see, one series wet becomes from dry to wet, the next series becomes wet to dry. You step by step, then get the flooding. The important for wet dry treatment is the timing. Now, every model you run for wet dry point, right? So eventually all water come here, you all get the regions wet, flooding. But the most important, you look at the timing, right? That is the flooding period, can be really matching the time you measures. For example, estuary, for example, you get a intertidal zone. When the flooding come here, probably, first like 1 hour, they only flooding the region had a nearby the main channel river. Then get a maximum tide, they probably get a flooding whole large area, right? So then you look at time series, you look at time, water level changes. So you want to make sure your timing, your prediction coding should be good, right? So another thing is draining. When the water becomes from wet to be dry, you want to make sure the water can really join in back to the river, for example, right? But also timing need to be good, right? When we do this kind of FVCOM testing, so we really care running. I run for pond, the kind of Princeton model. We also did the Princeton model. Also, we run for econ side, the Princeton model. So both had a wide dry point, right? So then we find, flooding period, that's two models do the pretty good job. But then draining point, we find, pond and the econ side, we also working with the Miller, the people working together like Bloomberg. We find that timing is too fast, right?
Professor, what do you mean? What do you mean timing? I cannot
Timing. Now, for example, you have
timing. Can you
timing,
spell
timing, time,
time?
T-I-M-E, time.
T-I-M, time.
That's a timing.
Hmm.
Timing means, okay, for example, you're flooding, right? You have a water flooding. So when the flooding time, for example, your water come here, so water will become get a more, the region get a larger be covered by water, right? But if you only compare the maximum flooding, okay, you see, my mother showed the flooding, right? But however, so this maximum, you reach the whole maximum flooding, you can be the 1 hour, you can be 2 hours. You see me? You can be 10 minutes. That's called a timing.
Mm-hmm.
You see
Okay.
me?
Yep. Yep.
Right?
Yep.
When I stayed here, when I stayed the location, when this is my location will become from dry to wet, right? But supposedly it should be 2 hours later, I becomes wet. But now my model not very good. But 1 hour it becomes wet. That's why for the wet dry point training, we spend a lot of time because if you look at my paper I published, I suppose published it many years ago. I didn't publish the paper. We has been remote sensing. We had a airplane to fly one X-ray with South Carolina. So we get a every hour slice, which region with the flooding region. So you compare your model at the same time, right? That's your area and the flooding area is every hour is the same as the observation. So this way you can test it that your method is good enough, right? Also, with the draining time, when after flooding, when the water was withdrawn back to the estuary, right? Though you can see if you don't design in the coating good, good design, good smart designing, you probably can too fast or too slow, right? So that's the issue.
And actually, another thing is especially when drying, from
Yeah,
wetting to drying,
yeah,
we should specify certain critical depths.
yeah.
So depending on the that value, sometimes the model shows unstable or some kind of making a noise. So
Mhm.
another question would be how can we kind of decide the
Yeah.
proper value?
I can tell you history about this. When a wet dry point was first developed, I think they developed, I think from the model, I could remember like a 2D model, some kind of finite element model. I couldn't remember the exact name. So then they use a 20 centimeter about the minimum. Then the model can be run very stable all time. If you put a FVCOM as 20 centimeter, you can all stable. You don't have a flooding driving issue, no unstable issue. So I had a paper published. I give you the profile, how these things changes, stability, numeric stability changes. So the changes come out of two issues. One issue is come from the mixing. The reason because when you have most of the time flooding very stable, most time coming of a draining. You call it draining period, we call it draining period. But this period is because you see, if you use a constant mixing coefficient, you don't have a problem. But now that we use the turbulence closure scheme, right? And the turbulence closure scheme, so you get a vertical profile of the turbulence kinetic energy, eddy viscosity.
Hmm.
But the profile when you get a very short water, most if we happen on the critical layer. For example, you saw your critical layer is 5 centimeter. Now your water stays at 5.1 centimeter. Okay, so that means really the wet water layer you think is 0.1 centimeter.
Hmm.
In this way, you can see your turbulence closure and the profile is very sharp, right? Because the energy zero surface in the bottom there, you get a very sharp grading.
Hmm.
So this
Hmm.
way you can make because different region different, that can make the model could behave, unstably.
Hmm.
So what if we treat this method? So when any region, water becomes a flooding draining because it's more water not very high, right? So we don't assume the vertical, profile and the turbulence closure. We do the vertical average.
Hmm.
So when you do your calculation turbulence closure model, you get an eddy viscosity. So when the water is dry and the wet point, we do the averaging. We only consider averaging eddy because the water too shallow, right? It doesn't make sense to make a vertical, like a profile. In this way, the model becomes stable. But then it still means, you cannot make the kind of critical layers too thick. If you make it too thick, you probably change the physics,
Hmm.
right? The reason because you put a 20 centimeter there, it's stable. But however, you
Hmm.
can see your flooding, okay, the period you're flooding, you probably get the water levels different,
Hmm.
right? Particularly you
Right.
consider for wave,
Hmm. Hmm.
right? The wave, because wave energy depends on the water depth. You cannot you didn't find a significant difference, but you do see the difference.
Hmm.
That's why we always recommend people use a 5 centimeter.
Hmm.
5 centimeter critical level. This way we find this way you can keep the models become stable. Also, your knowledge affect your physics, right? So you don't get a more water column over there, right? That's why we use a 5 centimeter. But some people try to very small, like 1 centimeter. You see the model will be also 10 step will depend on the water critical level you choose. Right? If you choose a very thin critical layer, you have to use a smaller 10 step. Okay, so if you choose like a thick layer, so that's why the people show you. Some people just run the model really stable, so they use a 20. Lot of model use a 20 centimeter. Okay, the first time we write the paper, my paper mentioned that. When it started fronting joining the white issue, you had a two approach. One is called a moving boundary theory. Okay, it's just like the boundary keeping moving, right? Another way is just wet dry point. At the beginning, scientifically, moving boundaries more make sense. If you want to write a good paper, like a syrup paper, moving boundary really makes sense because you look at the water column, you can keep the water is a water will definitely is conservative. But a wet dry point is the issue come out. You get the flooding, they can conserve the mass. When you're drying, no. Right? Drying, when the velocity become from wet to dry, right? So the water just disappear. They not put the water back to the wet point, right? That's why your model was a flooding period is a conservative volume, but drying problem is not a conservative, right? So that's why for the way of the science, you find that the first method is better, but when you run the model really case, you find the first method really hard because you get actually so complicated geometry, you have a lot of tidal creek, so you don't know where your moving boundary is. Also, boundary is probably interactive because you get a water come from main river, you go to tidal creek, you can be flooding this side, you can flooding another side. Right, that's the unstructured grid model and the structured grid model. I had a paper published in 2008. Okay, everything invited me to actually walk to talk there. I compare with the Princeton model and the FVCOM because I used the Princeton model before. I found that both models show flooding draining. However, like all structured grid model, like a raw, like a Princeton model, any structured model, flooding draining like a 2 box. Because they don't result the tidal creek. So all water come from the main river to the estuary, just like a whole systematically moving around. But they don't have a multi flooding source because they don't result tidal creek. So when you get an unstructured grid model, you get a tidal creek everywhere. So water can come from the dry area, come from different place direction. That's why they get 3-dimensional flooding, but a structural grid model only 2-dimensional. Right? So then you want to put the particle in. I do the testing with the Georgia River. So we put a lot of seed in the upstream, the student. So then we put a seed in there for seed flowing in water. So then we go downstream to wait to how much seed you get, for river. So we found if you use a structure, I use a pond, like a econ side, a prediction, we are still predicting. We thought it should be here. Then we go there, we found it. No, not there. So then we use an unstructured grid model, we know they go to a different direction. So then we go there, we find it, so they do. You can see like a different location, not just only main river, right? Go to a different creek like region. So then we use this one to approve. So actually it's very complicated, right? You cannot apply the structured grid model in the estuary to do the flooding draining. You probably can do the main river, fix it. You can do a pretty good job, but then you get a white dry point. You face the problem because the water exchange. You also put a particle larvae fish. You can see the structural grid model larvae just moving like this way. No river and no like a wetland like this, but unstructured grid model you can see go different way, right? Because the different sources. Okay.
I mean, go back to Kyuan's question. I mean, let me just double check. So your answer is, I mean, when wet and dry.
Yeah, you don't
Uh,
have boundary.
so but actually, if the between the wet and dry
Yeah,
that section, that cell,
yeah.
I mean, that is kind of a treated. I mean, how can I express? I
No,
mean
no, that's not a boundary condition, but they have a mass conservation issue. Because
so.
when you have a wide and a dry,
Mhm,
right? So for example, you will become this point dry. That means all velocity equal to zero on a dry cell.
right.
But then what happened, your wet cell you get a velocity,
Hmm.
but you get a sea level.
Right.
So then what happened? So when you get a flooding case, you measurement on one cell, the
Hmm.
three node, you measure the sea level.
Hmm.
So then you find the sea level is higher, right? So then the cell should becomes wet.
Hmm.
So this way, because before you get wet, before it's dry, the first equal to zero automatically.
Hmm.
Okay, not that you specify, it's automatically zero.
Right.
So when it becomes wet, so then what happened? Your sea level has to calculate it first. Okay,
Hmm.
when it
Hmm.
becomes red, then it's dry to wet. Then your momentum will turn on. You get a flux in.
Hmm.
You understand? You see what I mean? So that's why you get a velocity and a sea level judges knows consistently, right?
Right. Right. So question is, so let's say this is the dry cell
Yeah,
and this is a wet cell,
yeah,
and still the water level at wet cell is not as high as the dry cell. Then
yeah,
the lateral boundary for between this cell, the
yeah.
lateral boundary, I mean, that is kind of a non-slip
No,
condition.
no. For example, you had a seal. That's the dry seal. But a dry seal, if you had two type of dry seal, one is completely dry.
Mhm.
Another is the boundary between the dry and the wet.
Yes.
Between the dry and the wet, you probably have two nodes.
Yeah.
That's the wet.
Right.
But then you have one node, sea level is equal to zero, the dry.
Okay.
So in this way, you determine it's dry, then velocity equal to zero.
Mm.
Right? In the cell, because no velocity, okay?
Mhm.
You see what I mean?
So that means it is somehow treated as a non-slip condition.
It's not a treat about it because they're dry, they don't have velocity. That's why you're not a boundary condition. They
Yeah,
say
yeah. But
fine. Certified because certified boundary condition is not they don't have a boundary just because you dry. So this means that you get a velocity in cell, but this two node is wet, right? But in another cell is dry, right? So that's why the
Mhm.
velocity equal to zero, right? But still the velocity in the cell is not they don't have a boundary. Velocity is probably still going to the dry point, pointed that
Mhm.
way. But however, because the velocity was in the cell, not in the node,
Mm. Mm.
right? It's not a boundary issue,
Mm.
right? They automatically certify the boundary, just no flux boundary condition. If they know no flux because you get a one point is dry. That's why you just have no. They automatic because you don't run for no momentum, right?
Mm.
Momentum is zero. That's why your velocity just certifies, there, but it's not just boundary condition, not like zero. If you no flux boundary condition zero there, then you get into trouble,
Mm.
right? You see what I mean? So
Mm.
that means if you specify the boundary condition, so then all velocity will be go around for the boundary, not the normal to the boundary. Okay, then you get into trouble. Then you don't have flooding anymore.
Mm.
All water will turning back. Okay, so if you look at our white dry point paper, I was finally published. You can go there. I described how the method working. Okay,
Okay.
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 Kim, I answer your question.
Oh yeah, thanks so much.
Okay. So now I think I answered the third question. Now I think Dr. Lee can answer the second question.
Yeah. Let me share my screen. So for this question, may I ask who asked this question?
Yeah, I think it's
I was
Jimmy, is that
asked,
you?
I
yeah,
think
that's me.
Okay, so first I want
Mm-hmm.
to double check with you. So you first installed the ESMF on your own and then use this one to test the ESMF. Am I right?
Yeah, right. Yeah.
Okay, so here is the thing. So I checked all the settings here. So first, this is the setting that you set for the installation, and after that you try to use a built-in application, the ESMF direct coupling as test to to test whether you have installed the ESMF correctly, and then you found that only one CPU or processor is running, and all the other five doesn't work so hard, right? So here is the thing. Based on this figure, I think for this case, your installation should be right. So here is why. So first of all, this one, the ESMF direct coupling as test. This is a very old testing coding for ESMF. I think it is before version 5. It's very old. So I think as soon as ESMF was developed, so this coding was there. So this is a kind of a old case. So within this case, the ESMF will first allocate 6 CPU to run the whole coding. So just as what you have done here. And then there are 3 different kinds of jobs. The first part is OI, so which means to you can just imagine that as wolf. So it is one model, and then the rest of 5 CPU is the second model. So I can draw a figure here. So originally there are totally 6 CPU. Okay, I draw one here. So 6 CPU. So originally, ESMF will first allocate this one to the OI components. So you can imagine this as one single model. And then the rest of 5 CPU run for the second model. In the coding, I remember it is called the model components. So you can consider the OI as wolf, the model as FVCOM. And then there is a third part which will use all the 6 CPU to run the coupling, so to do the data exchange. So it is okay if you see that only one CPU is running. It means that it's within this part. So IO components is do the calculation. So maybe for the next step, the other 5 will run very hard, and the CPU 0 is kind of free. So maybe the thing you can check is to double check this case while running and to see whether after several minutes the same situation happens. Okay. So
Okay,
this
I
is
will
the
check it.
mhm.
so you think about his order doing his installation should be correct.
So far, based on this figure, I think it is okay. So maybe I think Gmail can run for another several minutes and check the CPU status again to see if anything changed.
Yeah.
Yeah. So this is the first thing I want to mention. The second one is that I think maybe you can try other coding to test your ESMF installation because as I mentioned, so this application is kind of old and maybe sometimes it doesn't work well with a new version. So one suggestion would be let me share another screen.
Mm.
I checked my my file to see here. So when I do the coupling, I also have the same issue. So after ESMF was installed on the cluster, I need to make sure that they are working. So when I do the check, I use this codings to check whether ESMF is okay. So this codings mostly is also from the ESMF official website. So for example, the one that I use most is this one, ESMF underline two model. So for this one, it is a similar thing. It will run the coding with several different CPU and define two separate model and then do a simple coupling. So maybe you can try this case. So if this case runs smoothly, then it means your installation is correct. So in order to find this coding, you can go to the website, this one.
Okay, you probably put it on the chat.
Yes,
The
I
link of the
will
chat
put on
there.
the
So,
chat. Yeah.
then the
So
Jimmy, okay,
yeah, so I think this one maybe is better for you for the testing. This coding is much newer than the one that you test.
Okay, I will try to test
Yeah,
that
Mhm.
code. Yeah.
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 And also a third thing that I want to mention is that let me go here. So in your setting, I found that here you set the optimization level as 3. So this is good for your future use because everyone want to use a higher level for the optimization. But however, sometimes we might find some issue during the installation. So in that case, usually I would suggest you to rechange the optimize level maybe to the default 2 because the higher the level is, the more dangerous it is. Okay, so although it will make your model running faster, however, sometimes it could cause some issue. So that is why the ESMF official sets the 2 as a default, so not 3. So after all the checking, if you still got found some issue, so maybe you can change this number from 3 to 2 and then recompile the ESMF on the cluster.
Okay, I will check that. Thank you.
Yeah.
I think so. Yeah, that's a very okay. Okay, that's a very good suggestion. Yeah, you can try. If a question, you can send Professor Lee the email. Okay,
Yeah.
good. So, if do I have other question? We can free discussion. Okay, all right.
But
So you
then
can,
first,
yeah.
Ken, could you go back to the Mobini's, Mr. Esan Mobini's question? I mean, about the scheme. You said that between the TBD and opt-in scheme.
Yeah,
So your final suggestion is we should use the TBD with the MP data scheme
yeah, yeah.
for any kind of tracer
Yeah, I think
modeling.
any kind of tracer model, even for dye experiments, we also use the KVD method. The reason I think KVD also include like most likely the MP data. The MP data because the tracer not only got a one direction, advective, it also got vertically. But MP data is a second order, very it's a positive second order, method. So this method can make sure you get a very high accuracy vertically. So this way, you can make much better. But if you only use the KVD, you didn't see much different. Okay, from compared with the upwind scheme, the FVCOM original setup. But FVCOM also, no upwind scheme also we suggest you every time to the tracer, you better turn on the MP data. No matter use the upwind scheme, no matter use the KVD, TVD method, both should be turned on. But after turn on this one, we still feel like an experience we did. We still found like a TVD method plus the MP data, the performance better. Okay, you can see the picture. You can look at this one here. You look at this one here. You did not okay. No, it's like a much different, right? The difference very small. Okay, right? But difference very small. You can see you can see this. You see that this one here. So this one, okay. This one is a left side is FVCOM original scheme. Okay, so then what? Okay, this is what is the 3D arcade. Remember? I forget a long time.
It should be the Rajkota.
Logic CUDA. Oh, let's compare Logic CUDA.
Yeah.
But Logic CUDA don't much a problem. So also people think about you should have a Logic CUDA high order integration. Then when you find a Logic CUDA, you use the Logic CUDA without a 3D Logic CUDA integration, include 3D Logic CUDA integration. You didn't find it much different. That's why you don't need to turn on that one. Okay, that's not a. This one we talk about upwind and a KVD method. So this one you do see, you look around here, you keep moving around here. You see this one, you see the green, the width of green is a little wider than that other one. Okay, you look at the color, you see. That's why your upwind scheme, even you include MPD data, numerical diffusion is larger than TVD method plus MP data. But however, if you take the MP data out, this both very similar. But when you add this one, you can see, you see here, okay? You see it had a very high, the numerical definitely diffuse, right? But you can see that this is still very high, like a dark red color. But this one also becomes, just like a red. Okay, that's why I would suggest you use a second method. Okay.
So in this example, there it is the diffusion should not be happened. The test case.
No, this case we don't put diffusion in. So we
Okay.
just use the method to determine which scheme cause more numerical diffusion.
Right.
So
So
numerical diffusion. Then we
so
find
in-
upwind scheme is have more diffusion than the TVD method.
so any kind of diffusion that is purely numerical.
Yeah, that's exactly. So you test all the numerical model, no matter which one they use, they should show you about this, right? But then I told you if we put a pound there, the model, you put other model like a before the run, they diffuse really quiet. That's why the run was used like a fourth order before. Okay, this is very high accuracy, but then we found a fourth order. Yeah, you do have more high accuracy for direction, but you can cause oscillation. It causes oscillation. So after Dave Hadelberg, but he passed away right now. So a lot of history. Dave Hadelberg developed wrong. Dave Hadelberg and I working together. I developed FVCOM because we are very close friends. So then after we are testing, we published a paper jointly. So then Ron was changing the third order. Try to get the oscillation gone, right? So that's why, but the good thing is if you look at my paper, published, my poster published, wrong FECON comparison paper. So they mentioned that, wrong had a high order approximation. So you make a resolution higher, it did not change the structure, no change the, accuracy. If you accuracy like a high order, you keep this one, even you make resolution really high, their accuracy still remain similar. But FECOM is second order. That's why if you get a compare with second order and the fourth order, runs better than the FECOM because that's the fourth order, right? But then, however, FECOM can make a resolution higher. Then the converging really fast, right? That's why, that's the reason we use a high resolution model. So this way, that's consistently with the numerical calculation, that's like accuracy. With fourth order, definitely more accurate than a second order. But then, however, I don't encourage people use the very high order, right? Approximation to numerical scheme. The reason because high order can cause a nonlinear artificial mode. like a wave. They can cause oscillation.
Mm.
Now I can show you the theory about when you get a high order mode, right? You can how the oscillation can come from. So you get a lot of artificial physically, oscillation.
Mm.
But that's why I try to, first order model is too low because it's linear. First order, that's why
Right.
you get a damping. But second order enough.
Mm.
So then, because second order, you still get not it's a little bit non-linear, right? Not hyperbolic. This way, you still keep the same shape,
Mm-hmm.
but more accurate. But so this way, you can make it. You still get a true physics include, okay, not include other artificial way, but then you get a more high orders. I mean, when the time when they develop a spectrum model, so they will develop a nice order. Mona, he feels excited. Okay, he showed me nice order how accuracy is. Then I thought I said, nice order is good. However, if you look at the code tree, you get a lot of artificial mode. How you know which one is a true mode, right? But that's model we developed almost 5 to 5 years. No, then nobody uses that because so then they have to just give up. They come back to the kind of third order. But a lot of discussion, but it's good. The people discuss each other, the share information, but they had organized was come from same advisor. Yeah.
Professor Chen, actually, I mean, this is not a question, but when I teach the FVCOM course for students,
Mhm.
I mean, it is better. I mean, if is there any material where very simple but basic code and equation for understanding FVCOM? I mean, for example, for the many students still very confused about what is a cell and what is node, and the way that FVCOM, how the FVCOM is code
Yeah.
for solving that equation using finite volume method. So
Yeah.
if there is, but actually, honestly, FVCOM as of now is too complicated, it's too heavy. So it is almost impossible to where that code is where. So if, I mean, in old days, maybe the Asian FVCOM original sample set where students can run on the Windows so
Yeah.
that you can understand basic equation, basic, simple GFD equation and the code in a Cartesian coordinate. If there is that kind of set, that would be really, really helpful
No,
for.
we do give you, no, we do have a lot, when FECOM published the paper in 2003. So we do have a lot for benchmark testing case. It's very simple. But then the coding also very easy to understand because this time we don't have the parallel running. Without the parallel running, like if you look at the Palm model,
Mhm.
okay, like a econ side model, it's very easy to understand. The
Mhm.
reason because they don't have a parallel.
Yes.
Mm. So they only can do the parallel for the open MP because just a coding organization, but not just a parallel coding, not an MPI.
Right.
So when FVCOM was come from, developed first time the Fortran 77 coding is not a parallel, so everybody love because a lot of people like old model love.
Uh-huh.
But then FVCOM want to increase computer efficiency, we change it to the 3.1 version, so include all parallel in there, coding hard to understand.
Mhm.
But then you have an option. So then you easily, so for user, for people ready to develop coding, they like the older code because it's way easy for them and then they can easily change it, right?
Mhm.
But however, for computer for model development, we had to go to
Yes,
the advanced
I
way.
know. Yeah.
So then we do have a lot of example for the case there. We get like a cylinder case. We get for example, we get a cylinder case, see how to pump the wind driving. So we get a compare with analytical solution. But that's a compare. It's all a compare analytical solution. So you look at my paper there. But however, that's a whole. So we don't have a student to go through because we all get a coding because set up on all the coding. not
So
in
my
your
question
case.
is, so my question is, can we find out the
Oh, we
FVCOM?
have all the case still there. But the
I mean,
problem is we just need the people to rerun the model because that's why, but problem right now, I tell you, the reason I said it's too difficult because all the setup, because you want to compare analytical solution, you have to change the coding. The coding only for one use for this case does not use another case. For example, we had a wind driving, we assume the fraction equal to 0, right? So you had to go back, turn on all fraction out. So we assume, okay, we had assumed nonlinear advection equal to 0 because you can compare that solution as a linear case, right? So then you had to turn on all the case off. So this coding only for use this case. But now the problem right now, we don't have a student, we don't have the effort to go there to clean this coding for a special case. But we do have a case for older one. We can probably find out. I don't know. I do the older one. I don't know where I can find. But I have a lot of fresh disk. Okay, include all the model. But I don't know. I don't know if we still can read or not because I had all the case. We got a different case and a disk. So if you can, we can find out. But this is very old coding. So our
yeah,
computer analytical solution. No, we got analytical solution come out of comparison. But problems we don't have. To be honest, okay, I don't have the effort to go back to look at all the questions. Okay, to get because you need a big assumption. Like I told you the story. The MIT had a student. They want to calculate the internal weight. No, like Kevin weight. So he run a model. He said, no, FECOM not good. I run I never compare analytical solution. Right? So then he said, I already turned on the nonlinear 10 and nonlinear 10 there, but why you still not get a solution like me? So then we said, okay, then he complained. So we had a postdoc working with him, showing you not only turn on the nonlinear 10 in the momentum equation, you also need to do if a linear internal way and the current way, you have to turn on the sea level. Right? The sea level, you had to nonlinear interaction, you had to turn off. You had to change the surface boundary condition like this way, exactly same kind of analytic solution. So after doing that, so after we have been working out for 1 month, get the whole setup there, compare exactly same analytic solution. But then he want to include some other 10. We said, sorry, we don't have the time to working on this. So because he do the laboratory experiment, right? Because this is a lot of time because you need to make sure you're coding exactly same the condition was your case study. So that's take a lot of time. Okay, right? Anyway, okay, time is over. Okay, 17.
Yeah. So so thank you so much for everyone joining this discussion. So if you still have any other questions, so you may raise it on the discussion board or just directly send email to Dr. Chen and me. And also, as suggested by Professor Wu, so it would be better if everyone can send the questions to us in advance before the next discussion so that we have more time on the discussion. So thank you so much for joining and have a good one. Yeah. See you next week.
okay.
Bye
Thank
bye.
you.
Thank you.
Bye.
Bye bye.
Bye.
Bye.